Hey guys, I'm Pat Kelly. Okay, in this problem, they ask us to find this indefinite integral, but even the directions say to use the formulas, which I have written up here for you. They're from one of the theorems you would have had in this lesson. So I kind of like this type of problem, where it's really kind of like a matching game. We've got to get our problem, our integral, to match one of these. And what we like then is that the answers just spit right out. The challenge then is making sure that you can get your given integral to match one of the basic forms over here on the left side of those equal signs. Okay, it's really important to pick up on the patterns that you're trying to match. In particular, there's always a u squared and an a squared, okay, and you actually see that in each of these three formulas. So back to our original integral, the one that we're working on, the a squared is not a problem. I mean, I have a constant term there of 1, so my a anywhere here can easily be 1. So you start to look at the other pieces of the puzzle. For one, two of these formulas have square roots, okay? And I have a square root. At this point, that would lead me to believe that I'm probably going to match either the first or the third. I don't want to rule out the second yet, but probably because of the presence of the square root, I'm going to go with the first choice or the third choice. All right, here's the next thing. I'd even mentioned how we have these u squareds, both first and third, and even the second, by the way, but you need the independent variable squared. And in my given problem, I actually just have x. I don't have something squared. So in order to force my given integral to fit one of these, it doesn't fit the bill yet. I'm going to play with it a little bit, try to manipulate it a little bit. And one of my go-to moves here is use substitution again. So I'm going to get started here and let your u equal the square root of x. And see, what's motivating my choice there for u is that if u equals the square root of x, that right there, that term, is u squared. Can you see it? Because that's key. If you can see it, that's key in terms of matching one of these formulas. I will have the independent variable squared. Let's follow through with this attempt. A lot of these are just attempts at first, and you see how far you go with it. But let's follow through with this attempt and see if it's going to match then if I figure out from here what my du is going to look like. So x to the 1/2 power, put the 1/2 in front, and then drop the power down by 1. And then dx. Okay, a reality check then to see if this is going to work. This x to the -1/2 is actually right there, right? -1/2, so it's downstairs. dx, okay, good. And I'm only off by that constant factor of 1/2, and constant factors are never a problem. I'll just bring it all the way out in front of the integral as a 2. So let's take this given integral and rewrite it as 2 integral. The square root of x in the denominator and the dx are going to become du. And downstairs, the other factor there of that square root is going to be 1 plus the x. I'm looking at it as a square root of x squared, so that's u squared. And that's actually what started our thought process, trying to get a u squared, and it worked. I like this. This now does match one of our three formulas, specifically the first one, right? Who cares about the 2 in front? I just have a square root downstairs. My a is 1, my u squared is there, and if I have addition, the order doesn't matter. So I have exactly this first formula, which means I can spit out my answer. This equals, and I'm following the right side of this equal sign here, where my u is actually going to be square root of x, and my a is just 1. So this equals the natural log, parentheses, the u I see in the formula, that's just square root of x for me, plus square root u squared in the formula, and that's just going to be x for us, right? This u, but squared. In the formula, we have plus or minus. That refers to whichever sign you had, addition or subtraction, in the original. So we had plus, so we'll still have plus. My a squared, a is 1. Close the radical hat, close the parentheses, put a plus c, and close your book. You're done. Don't close your book. You probably have more homework, but that's it for this problem. Okay? Strategy is take your given integral and try to get it to match one of these. Focus on the independent variable squared, whether or not you have a radical, and also the order of these sometimes will matter too, especially when you're dealing with subtraction. Okay? Go try some on your own.